Hello everybody, this is Dr. Vahid Aryadoost here. In this video, I'm going to demonstrate how to do a multi-group structural equation modeling using AMOS, the software called AMOS. Before I start to explain what multi-group SEM is, I would like to suggest that you watch some of the previous videos that I have created about confirmatory factor analysis and structural equation modeling. Actually, these three videos. I will leave the link here in the comments section of the current video for you, so you can watch the videos before that. And also, I would like to encourage you, if you have some free time and interested, to read one of the chapters of this book, Quantitative Data Analysis for Language Assessment, Volume 2. The chapter is basically Chapter 5, which is about structural equation modeling in language assessment. Now, multigroup structural equation modeling is not very new, I should say. It's very powerful in the sense that it allows you to test the differences in the parameters of your model across different groups. For this analysis, I have two groups, males and females, and I want to test whether the effect of motivation, positivity, and strategy on English proficiency is different across genders, that's females and males. So I'm specifically interested in testing this hypothesis. Hypothesis number one, which is actually general one, whether motivation, positivity, and strategy have an effect on English proficiency. So that's hypothesis one. But more importantly, whether the effect of motivation, positivity, and strategy on English proficiency is different for males compared with females. I am very much interested in these parameters. And of course, you can select to choose different types of multi-group analysis. You can select to select a model to which allows you to test whether this parameter and any of these basically regression coefficients are different across males and females. You can also check out whether the residuals are different, the mean and intercepts and so on and so forth are different across the two groups. But I am only interested in this hypothesis. I would like to see whether these three latent variables, strategy, positivity, and motivation, have an effect on English proficiency, and if so, whether this effect is different across males versus females. And in order to do so, I want to look at the differences between these three parameters, which are indicated as B1, B2, and B3. Now, B1 underline 1 is this parameter for group 1. We also have an analogous parameter for it, which will be B1 underline 2, and B2 underline 2, and B3 underline 2 as well. Okay, so we will estimate these parameters for males and then for females. As you can see, for example, B1 underline 2 versus B1 underline 1, and so on and so forth, as I mentioned before. And then we will compare the parameters across the two groups to figure out whether there is a significant difference between them or not. So I am going to show you the data that I have. This is from the core project, which is a project that was led by Melvin, my colleague at NIE. Basically, this is a partial data set. The data set is much larger than this. And we have gender as one of the groups, and those three latent variables, which are indicated by several observable variables. The first one, which is motivation, is indicated by these three variables, motivation, and these are the items. If you're interested to read these items, please pause the video and read them. Then we've got positivity, which is indicated by 3 parameters in the same time, and strategy, which is indicated by 5 parameters. Like I said, the number of parameters are more than this. The number of latent variables are also more, but I'm just presenting these in this screencast. Then we've got grammar, vocabulary, comprehension, and writing total score. That's a situational writing task, and that is how I'm going to represent proficiency in English in this analysis. So this is an SPSS file, SPSS version 27, and AMOS in the same way is also 27. And I would like to start the analysis now. As I have explained in previous videos, we need to draw the diagram first. I have already done this just to refresh your memory. I'm going to just do a very quick draw up for you so you will remember how it's done, but I'm not going to do everything. So you should click on this draw a latent variable button and then put your cursor on the interface and then drag it to the right side or to the left side, so you will get this oval shape which represents the latent variable, and then keep left clicking on it till you get the number of parameters that you need. And of course you can use this kind of rotate indicator button in order to rotate your parameters in any format that you would like to. But I'm going to continue doing this because that's basically what I have explained in previous videos. So in the interest of time, I'm just going to remove these parameters and stick with what I have. Now, I have this model which indicates that motivation has got 3 parameters and positivity has 3 and strategy has 5, versus English proficiency, as mentioned before, which has got 4 parameters. Now, I need to connect or link my data set, which was in the SPSS format as I showed you before, with this model. So I go through select data files from here. This is the easier way. Of course, you could go from one of those buttons on top. File name, and you'll find your data, which is structural equation modeling in my case, and click open. I'm not going to click open because this is already open in my case. So you need to make sure that the number is correct and it basically is consistent with the number of persons or participants in your data set, and then click OK. Now my model is connected with the data set, but in your analysis you might notice that you still do not have the names in your oval shapes and in your observable variables. So what you should do is just to click, drag and drop those models, those names one after the other into the observable variables and just leave it, and then the next one drag and drop, and so on and so forth. For these unobserved variables or latent variables, what you should do, I'm going to close this, is to double click on the unobserved variable and then just type in the name of each of these variables. Right. And notice that I have this disturbance or error of measurement which is linked with English proficiency. In the default model you won't see this, but so you have to do it. You have to add it to it manually by clicking on this button here, and once it's activated, you put the cursor on English proficiency and click on it. So this will be added to English proficiency. We add this because this is an endogenous variable and it needs this variable, and these guys are exogenous variables, and as a result they don't need this error of measurement attached to them. So let's get started and estimate this first model. This is how I will do it. So I click on Analyze Properties. First things first, under Estimation, make sure that you've got maximum likelihood checked. If your data is normally distributed, if it's not normally distributed, then you should choose other types of parameter estimations. Please watch my previous videos. I explain these in some details. Then if you have missing values or missing data in your raw data, you should check estimate means and intercepts. I do have it, so I have checked it. And then I go to outputs. Under output, maximization history, standardized and standardized estimates, and squared multiple correlations have to be checked. If you're interested to look into the normality and outliers in your data, I suggest that you check this as well. So you can click this, that would be enough for the time being, and click calculate estimates. Then the output will appear automatically. If it doesn't appear, don't worry about it. You can just click on view text, and well, basically you'll get it. The first thing we need to look at is always the model fit. I have explained these model fit statistics before. Very quickly, we've got the chi-squared value followed by p-value, degrees of freedom, and then chi-squared value divided by the degrees of freedom, which gives you a normed chi-squared. This should be ideally below 3, so I acknowledge that this model is not extremely a good fit yet, but based on the CFI, which is you can click on CFI and you get more information on CFI, which is the comparative fit index, which was proposed by Benteler in 1990. Basically, the model is pretty good because the CFI falls above 0.95, as you see, and this TLI, Tucker-Lewis index, also falls above 0.95, which indicates that my model is good. If you're interested to look at NFI, or normed fit index, it will also give you this, tell you the same story, which indicates that the model is pretty fine. And importantly, you should look at RMSEA if you scroll down, and this index falls below 0.06. It's an index of the amount of error, and it's pretty small. It's below 0.06 or 0.05 according to some different references, as I have discussed in the previous video. So the model is not really bad. This was my default model. Now what I want to do is to fit the same model into the data, but to separate males and females. That's something that I have already done. That's under model 2. I'm going to toggle to model 2. If you don't have model 2, don't worry about it. I'm going to click yes. So don't worry about it. You can just continue under your model 1, and then if you add on any parameters or you change any of the parameters, you can go to File and Save As. So it will be saved as a new model. You can call it, for example, model 2 or model 3 or something else. So then it will be listed under the list of the models here. So to continue, we first need to create different groups. In model 1, if you recall, we had group number. So what you can do is just simply click on group 1 and change the name to whatever you like. Then click new and change the name. So you first click on this and change this to male, and then female, and that will be it. So let me quickly do this for you. Male, and it will be populated immediately on the left hand side, and then click new and female. Okay, and then click close. If you do not like any of the groups, you can click delete and you can just remove it in this way. So I'm going to click close, and I've got 2 groups now. Okay, I've already done that, so I'll go to group 2, so I'm going to choose no, because I didn't want to overwrite the first model that I had created. I have 2 groups here, group 1, group 2, males and females. Now what matters here is that I associate data separately to males versus females. I again go back to select data file, and under this data file I will see the 2 groups listed for me. For the first group, I click on file name, go through structural equation modeling, and that's the file that I have. Then grouping variable, I click on grouping variable. My grouping variable is gender, obviously, so click OK. And group value, the first group is 0, which is males, and I click OK and click OK again. Oh, I shouldn't have clicked OK the last time, because I wanted to do the same thing for females. The process is going to be exactly the same. You need to associate the variable, which is gender, and the value, which is 1, and click OK, and we're ready for an analysis. The first analysis that I'm going to do is without adding any constraints, which means that I'm going to assume that all of the parameters that are going to be estimated are basically different for males and females. Click okay, let's go back to these parameters, just make sure that everything is in order. Okay, good. Estimation is maximum likelihood, estimate means and intercepts, that's also good, and click analysis, and the analysis is done. You go to model fit the model fit has improved somehow. It's better, so that's good news for us. It means that you can separate males and females. CFI and TLI and NFI remain to be fine. They're close to 0.95 and obviously above 0.90. And the error of measurement, the amount of error, root mean square error of analysis is actually slightly lower than the previous one, which is better. Now, so far, I have not applied any constraints to males and females models, because now I want to constrain these parameters one at a time, maybe one group at a time, to figure out whether the fit of the models will decrease or will not decrease compared with the fit of the unconstrained model. In order to do that, it's very easy. You have to go to model multiple group analysis, click on this, and this message will appear, which basically warns you that the program will remove any models that you have added to the list. It's okay, just click OK, and you'll get this box. If you do not have latent variables like positivity, motivation, and only have observed variables, which are represented by rectangles, some of these options will not be available. But since I have oval shapes or latent variables, all of these options are active. So it's important to remember that the number of constraints or the number of constraint parameters increases incrementally as you move up this list. For example, for measurement residuals, I click on this, and measurement residuals on the left side and on the right hand side in the model basically light up. So that's the only constraints that we have, meaning that the parameters will be estimated separately for males and females, but the measurement residuals will be constrained to equality, meaning that the model assumes that these residuals are the same for males and females. Now, for structural residuals, as you see, it's indicated by the check mark. It not only indicates, includes model 8, but also structural residuals. So I click on structural residuals, so it's it. This is structural residual. If you like to just constrain the structural residual itself, what you should do is to remove this tick. Now, for the third model, which is structural, so I'm going to check this back here. Structural covariance, what is happening is that you see the covariances of these structural, this structural part of the model are going to be set to equality. They're going to be constrained to be equal. Now, if you like to compare structural covariances and the rest of the models below it, this is how you will do it. So in addition to the covariances that are set to equality, which is this one, structural residuals and measurement residuals are also set to equality for structural covariances model. Now, if you move up to structural means, in the same way, the means of these variables are set to equality. What we're looking for basically is the structural weights, and I'm going to click on this, and as you see, these three lines light up, which indicates that this model includes all of the constraints that are in the previous models, but also adds on these three parameters. So this will be pretty good enough for us, actually a lot more than what we need. What you can do is to uncheck all of them and just stick with structural weights like that, or you can leave all of them and remove them later in the analysis. So I'm going to leave all of them as is and remove them later when I want to do the analysis. So I click OK. Okay, so all of these models, let me just drag this up a little bit so you can see. You can see the structural measurement model, which is the most, which is the model with the highest number of constraint parameters versus the unconstrained model, which is the model with no constraint parameters. I can double click on this and you see there are no parameters that are constrained. Click on this one and the number of parameters that are constrained are all here. All of the measurement weights, and measurement weights are basically these regression coefficients. So this model assumes that these have to be constrained, so they're not going to be estimated freely for males and females. In other words, they're equal for males and females, and these as well. They're equal for males and females, and these as well, and as well as these regression coefficients. So they're equal for males and females. That's what we mean by parameter constraints in the measurement weights. But what we are interested in is the structural covariances, and specifically, I scroll down, structural weights, I apologize, structural weights, and specifically in these three parameters, which are B11 and B12, that's for males and females, B2 and B3 males and females. We assume that they're equal. So I'm going to close this. That was just an elaboration of what's happening here. Now the next step is that I suggest that we remove the rest of the models because we don't really need to compare them with the rest of the models. So we click delete, and this one is removed. Delete. Structural covariance is also delete. We need structural weights, so we click on structural intercepts. We don't need it, and measurement weights, we can delete it. The reason why I'm deleting it because I'm not looking at those parameters, but if you're interested in looking at those parameters and their equality, go ahead and keep them. But you're going to see that the output is going to be a lot more than usual output in structural equation model. So everything is ready now. I have two models to compare with each other, unconstrained model and structural weights model. Basically what I am looking for is whether there is a significant decrease in fit when we add constraints. That's when we move from this model to structural. And if we do find that there is a significant decrease in fit, we must determine which path is invariant, which one of these three is invariant, or is basically different between the males and females in this analysis. And that is done by using a chi-square test, which I'm going to show you. So let's click on calculate estimates and wait for the results. All right, so we have to go to model comparisons. That's where the chi-square test that I mentioned before is reported. So we have a p-value which is statistically significant. What does it mean? It means that there is a significant decrease in the fit of the model if you compare the structural weights model with the unconstrained model. So basically there's a significant difference between males and females because the p-value is significant. So the parameter cannot be constrained. We cannot assume that the parameter is the same for males and females. There is variance in that parameter, in those parameters. But what parameter exactly? We don't know. This analysis doesn't tell us anything about that. So what we should do is to go back to the model and manipulate it a little bit to find out which parameter is actually significant. So this basically tells us that the two models are different, statistically significantly different, the unconstrained model and the structural weight. And now we want to see which parameters are also different with each other. So I'm going back here. So I need to do some manipulation here. The first model that I want to test is this model. That was B1. Then I will test B2, then I'll test B3. So I'm going to double click on structural weight, and I'm going to copy these three notations because I need that for parameter estimation in the new model that I'm going to create. I'm going to hit Control and C and click New. In the new model one, I want to test the equality of the B1 coefficient, which is this one. So I paste all of it and I just keep the first line. That's B11 equals B12. That's B1 for males for males equals B1 for females. New, and let's call this B2. All right, and click and I just paste everything that I have, but I'm going to keep B2 equals B2 in males and females. And then finally, the new one is B3, and notice that as I'm writing these down, this list is populated, by the way. And then I click B3, I click, well, I just copied and pasted these annotations, and I remove those that are not necessary because I want to just constrain B3. And that will be it, close. Now I have 5 models to compare with each other. Now these models are very much similar to the unconstrained model. I'm going to click on an unconstrained model. But so there is no parameter constraint. The only parameter constraint is B1 in the first one. And compared with the unconstrained model, the only parameter model that is constrained in B2 is B2, and in the same way, in the B3 model, the only parameter that has been constrained is B3. Okay. And now I would like to click on calculate estimates. So let's look at model comparisons. The most important table for us among all these tables is the first one. So the first one compares all of those models one at a time with the unconstrained model. And the chi-squared p-value will tell us if there is a significant decrease in the fit of the model or not when you are adding a new constraint to it. So B1, we have already figured out that structural weights is basically significantly different from the unconstrained model, as the p-value indicates. Now B1 is a model that is statistically significantly different from a unconstrained model. So it has a significant decrease in the fit. So there is a significant difference between males and females in this parameter, which means that we cannot constrain it. In the same way, there is a significant decrease in the fit of the model, B3 model. So B3 model cannot be constrained. We cannot assume that B3 is an equal parameter for males and females. In other words, this is B3 actually. In other words, strategy affects English proficiency in different ways for males and females. And B1 is also statistically significant. So which means that motivation affects English proficiency in significantly different ways for males and females. But positivity has more or less the same effect regardless of the gender of the population on the English proficiency. That's how we can make sense of it. Okay, so this is basically more or less everything about multi-group analysis. For the rest of these model comparisons, I wouldn't really be concerned about them because the most important thing is the first one. We want to compare the model with one parameter constrained at a time, one at a time, with the unconstrained model to figure out whether the fit decreases or not, and if yes or no, then the rest of the story. So I hope that you find this video useful. If you like the video, please give it a like and stay tuned in. I'm going to post more videos about other types of analyses and also structural equation modeling. Thank you very much and have a great day.